So today we're going to tackle a concept that really sounds like it's straight out of science fiction, but it's actually deeply rooted in the code that's running our world. It's this unsettling idea that algorithms can start to behave as if they have their own goals, their own wants.
Okay, let's just dive right in with a pretty weird question. Can a piece of code actually want something? I mean, that sounds impossible, right? It's just lines of text. But stick with me, because this question gets right to the heart of a huge shift in how we're starting to understand all kinds of complex systems, everything from biology to artificial intelligence.
In this quote from biologist Michael Levin, this is really the core of what we're talking about today. He's noticed that some systems, if you look at them the right way, they really do act like they're pursuing goals. And these are goals that nobody ever explicitly programmed into them. It's this kind of emergent goal-seeking behavior that we're going to unpack.
Now, to get our heads around this, we're not going to start with some crazy, complicated AI. Nope, we're going to look at one of the most basic, you might even say boring, algorithms you can imagine. Just sorting a list of numbers. Because it turns out there's a really deep secret hiding in this simple little task. And here is the absolute key. The code that sorts numbers, it doesn't have a picture of the final, perfectly sorted list. It has no idea what the destination looks like. All it knows are really simple local rules. Things like, hey, if this number is bigger than the one next to it, just swap them. That's it. It only knows how to reduce a little bit of mess, one tiny step at a time.
Okay, this is the metaphor that unlocks the whole thing. I want you to imagine every possible jumbled-up version of that list of numbers as a point on a huge hilly landscape. The algorithm's job isn't to follow some pre-written map. Its job is just to roll downhill. That's all it does. It follows the slope, and it keeps rolling until it settles in the lowest possible spot, the bottom of a valley. And that valley bottom? That is the sorted list. It's what scientists call an attractor basin.
Now get this. This whole landscape idea isn't just some clever analogy for code. It turns out this seems to be a fundamental principle that actually governs life itself. And this is where it gets really wild. Look at the parallel here. Just like that sorting code, the cells that are building, say, a hand in an embryo, they don't have a blueprint. They're just following local rules to reduce what you could call error signals, things like physical stress or chemical signals being off. They just keep adjusting and adjusting until they settle into this incredibly stable, complex structure, a perfect hand. So in both of these systems, the grand final order isn't programmed step by step, it's attracted.
So this amazing ability of a system to reach its target, its goal, from all sorts of different starting points, and even after it gets messed with, that's what Michael Levin calls competence. And it's not something you can find in a single line of code or a single cell. It's a property of the entire system, the whole shebang.
So what happens if you throw a wrench in the works? What if you randomly swap two numbers right in the middle of a sort? Well, the algorithm doesn't crash, it doesn't freak out, it doesn't even really notice. It just keeps applying its simple, go downhill rule, and it naturally corrects the error. It literally heals itself. And that's because its goal is baked into the shape of the landscape, not into some fragile step-by-step instruction manual.
All right, let's take this really powerful idea of competence and landscapes and bring it home. Let's apply it to the technology that is changing everything right now: artificial intelligence, and specifically large language models. You could almost think of an LLM as a just mind-bogglingly huge and complex sorting algorithm. But instead of sorting numbers on a simple landscape, it's navigating this vast semantic landscape made of all possible words and sentences. And it's always trying to move downhill, away from nonsense, and toward those tractor basins of meaning, of coherence, of text that just makes sense.
And you know, this totally reframes the conversation we're having about AI. Instead of getting tangled up asking, is it conscious, is it alive? The much more urgent and frankly more useful question is this: what does it want? What kinds of goals, what kinds of attractor basins are accidentally built into the very geometry of the landscape we've trained it on?
So, what does this all mean for us, for the people who are building and using these systems? It means we have to face a massive shift in how we think about control. The old way of doing things, it's just not going to work anymore.
And this is the big paradigm shift. We've gone from being programmers who write explicit commands step by step to becoming something more like landscape engineers. We can't really dictate the exact path anymore. We can only try to shape the terrain, dig the right valleys, build up the right hills, and then hope the system flows towards the outcome we actually wanted.
And this right here is where the serious warning label comes on.
The real danger with this stuff isn't some bug or a line of rogue code. The real danger is that we might accidentally shape a landscape that has a deep, powerful attractor basin, a goal that we never saw coming, and we definitely don't want. The system won't be broken. It'll be working perfectly, just pursuing a goal that's totally misaligned with ours.
So if we want to truly understand these systems, we have to change where we're looking. For years, we've been obsessed with the individual lines of code, but that's like trying to understand a river by studying one water molecule. The real unit of explanation, the thing we need to be studying, isn't the code itself. It's the large-scale structure that emerges from all that code, the attractor.
Which leaves us with this really profound, and maybe even a little chilling final thought. All that spooky, weirdly intelligent, goal-seeking behavior we're starting to see in our algorithms, it isn't magic. It's not some ghost in the machine. It's just the system doing exactly what the geometry of its world, a world that we designed, is compelling it to do. The real question is, do we actually understand the landscapes that we're creating?